Yo,
Woo!
what's up, man?
Love that intro, man.
Yeah.
What's going on, dude? I have no idea what's going on tonight.
Yeah, I ran out of time, dude. Literally still building a PowerPoint slide for tonight's presentation conversation. So bear with
You,
me.
you, you want me to? I'll ramble for like 5 minutes.
Yeah, just keep going, bro.
Yeah,
I'm in the tail end of something, and I think it's important that I get it finished before we just keep.
nice,
All right,
nice. Well,
so I will say this: labor of love, right here. Okay, so I didn't exactly like prepare hardcore, but it doesn't matter, right? Like this isn't going to be difficult to understand. I'm just using old slide decks and stuff and grabbing a couple pieces here, and I'm just putting the story together. That way, we have some material to talk about.
that's
So yes,
awesome,
so tell us a story, man, and give me like 2 more minutes, and I'll be ready.
bro. I've been going down the rabbit hole of mold. I've just been getting a bunch of guys on mold jobs and everything like that. So, what a rabbit hole, bro.
Yeah,
For dealing HVAC for years and then building performance, going down that rabbit hole like of mold and testing and stuff. It's really cool watching these guys work, man. It really is.
yeah.
Dude, we found like a mushroom up in the attic, bro. Dude,
Well, it's Florida, man. You know.
it's Florida. And when you keep it at 68 degrees, it's bound to happen. I think who got it? I think it was John Ellis that got it. I actually forgot what it was called. Let me see if I've got I think I have a link or a web page open of actually what it was called. It's wild, man. Basically, they did everything against what Rick Sims has been teaching at the symposiums in Orlando. Rick Sims is known as the what was it? Conduction?
Conduxation. Yes.
Conduxation?
Probably the best training video you'll find on YouTube.
Oh, killer. And
Yeah.
the funny thing is when we saw him last time, he's like, I've been doing this stuff for years, and that's what I get known for. He was kind of upset about it, bro.
Yep. All
But
right,
it was
man.
killer. It was killer.
I'm prepared. I'm prepared
All
to
right,
rip. Are you
let
ready?
me finish up now.
All right.
Basically, they
Okay.
did everything wrong. They put all the triangles and the ductwork sitting on the attic 2x4s and trusses, man. And it's oversized. We did a true flow grid, right? We did a load calc, and load calc said it was oversized. TEC's true flow grid said it was ductwork's not. It's just not making it. But that's it, man. Forget about it.
I
Did
hear
somebody
you.
just post that? Forget about it.
I'm sorry. Yeah. So yeah, burnt face, man. I've been at the baseball park literally from 8 o'clock this morning, and I got home 45 minutes ago. Literally left my wife at the park. I'm like, I gotta go run the show. I'm like, I know the final game isn't over, but I gotta leave. I'm like, I gotta
Oh,
go run.
Froggy Beluga. Froggy
There's like
Beluga's killing me,
there's
bro.
like 15 minutes left at the ballpark, final game, and I was like, man, the things I do for this show. I'm just saying, I ditched my kids' tournament ball game at the end, and I was like, sorry, I gotta go. Because I was like, man, I knew I wanted to build a couple slides before today got started. So, labor of love, people. Here
So
we go.
funny.
Yep. So I got burnt. I've been outside all day, literally. Or you could call it marathon training, bro. That's what this is all about. So, FYI, if you watch my personal Facebook page, I'm on a mission to break a 4-hour marathon time. And I run the Twin Cities Marathon this coming Sunday. This is my last week. So
Nice.
I'm in taper mode, which means my long runs are done. All I got to do is run like a 4 miler this week, and it's game on Sunday, man. Yep.
So total heat formula.
I know it's time to get into
What
HVAC. Sorry.
the heck? What does that mean, though?
All right, let's get down to business. You ready?
Let's get down to business.
Let's
You ever
see.
heard that song?
Yeah.
HVAC.
Let me share
priorities,
screen.
Froggy Beluga. I like that name, Froggy Beluga.
Let's see. All right, I'm going to share this PowerPoint. Well, hang on. Let me set the reason behind the title. Okay. All right. So I wanted there to be a resource where I could point people to when they call tech support. And I've had this question a couple times. Hey, I used the digital TrueFlow grid and the airflow is measuring low. and I've compared it to this or I've compared it to that, and it's like 4 to 500 CFM difference. Okay. And then I typically will go straight to the total heat formula and use it. And,
Okay.
and then I will explain it. And I think it's a little deep because it typically gets deep with people when I talk about the delta enthalpy thing. And they go, they're like, okay, I get it. Like they're like, oh, that makes total sense. But I also think if it's your first time hearing delta enthalpy, it's kind of like, man, that's kind of like that's deep, right? And it sounds deep and complicated.
It sounds
Well,
like double enthalpy.
that's right. Yeah. So
Just
so I was like, let's do a class where we explain how the total heat formula is being used as a resource to verify your tools, right? So like okay, the reason for this show tonight is this. I don't care if you use static pressure, pressure matching, a flow hood of any kind, the digital true flow grid, temperature split with a software program, or you traverse your ductwork. Frankly, I don't care, right? That's what I'm
okay.
trying to say. If you are taking an airflow measurement to get to capacity, the total heat formula is something you're going to want to know. Um, you're going to want to know it. It's going to help you vet out your airflow measurement to make sure that you're either getting good or you're getting bad data out of your tools or you're using your tools properly. Okay. And I know that's kind of like, Chris, what are you saying? All right. You ready? Let me explain, man. This is going to get deep.
All right.
All right. Let me just kind of do this right here.
I'm
All
not
right.
gonna say nothing.
I'm pulling slides from other slide decks, so I had to go delete my text at the bottom because I had no idea what was down there. I'm just saying. Because I'm riffing right now, dude. All right, so we're measuring. Let's see, my little one's interested. She
I
knows
did.
we're
I
live.
didn't.
That's why.
I caught her in the background. I was like, I don't want to mess his flow up.
Yeah, no, it's all good, man. All
So
right,
you
so
don't care what we're using. You don't
I
care if
don't
I'm
care.
using a flow hood.
I don't. This show's not about a product. It's about all products, right?
Correct.
You have
Yeah.
all these products. They make a flow measurement to some degree, right? And you need to know if you're getting good data, bad data, and how do you back it up. And I'm going to
Right.
say you should look at the refrigerant side of this equation and plug it into the whole equation. And I'm going to show you what that means. All right. So
Oh, he's
excuse
cooking.
excuse my rough slide building last 20 minutes of life here, but I'm just kind of throwing some stuff against the wall. So here's the formula, right? It is BTUs an hour, right? That's your capacity. And you
Okay.
can get to capacity by knowing three things. And the first one's real easy. 4.5. What is 4.5? Let's get this just out of the way.
Right.
We call it the constant in the equation, but what it breaks down to is standard air density times 60 minutes. Right?
Oh,
That is
you're trying to break that hour up and get me like a little bit of a snippet.
Yeah. So here's what I want to say. Let's don't focus too much effort in understanding the 4.5, right? It's
Okay.
air
Yeah. Yeah. Yeah.
density in minutes and it's a constant. And if it changes very little. And if it changes, it rarely changes the whole like capacity
Sure.
equation very much. You may swing capacity, I don't know, let's just say 300 BTUs. Really not a big deal in the whole scheme of things. So when I use the equation, I just stick to 4.5. Okay.
Okay.
Now, CFM and delta enthalpy, those can move and those can make big differences, right? Those are the
Okay.
two things that you're measuring and you want to get right. Okay. But they also complement each other very well, right? One, you rarely are going to have them two like super, super high and have this capacity that's going to be off the charts. And I'm going to get to that in a minute. And then
So
like something's not making sense here, right?
delta enthalpy is triangle HT.
That's right. Triangle
Okay.
HT.
Triangle HT.
Okay, so let's pick apart the delta enthalpy part. And here I'll do this. Let's do
Okay.
this. I'll kind of carry this over.
Triangle HT coming at you.
And if I botch something, I apologize. Like I said, labor of love, and I'm just riffing here. All right, so what you see on the
We'll
right,
just edit it out.
yeah, whatever, man.
We'll get it. Yeah, we got our guys on it.
So yeah, so like, how do you get the delta enthalpy measurement? right? That's probably what you may be asking. Like, hey, okay, well, how do I get? I know how to get CFM. I got tools that do that. What do I do to
Right.
get out the enthalpy, right? So typically, we all have probes now, right? You stick a probe in the duct, you get dry bulb, wet bulb, right? It can convert to enthalpy. So this, what you're seeing here, this is an enthalpy chart. Okay, you can look it up. This one's free. I just pulled it from the internet, dropped it on here, no big deal. And this in the column is wet bulb, right? So you
Right.
measure wet bulb, and then you literally just go over like 51. Let's just say 51 is what we measured. 51 point what? 51.4. Okay. And then you like 21 point, basically use the chart, you cross over, you pull the enthalpy measurement. Okay. So
Oh, so the top is like
it's
between 51 and 52. What's going on?
right, right. Like 50.2 or 50.2 or 50.3,
Okay.
right? We're getting in
Got
the weeds of the measurement, not just the
it.
whole
Yes.
number of the measurement, right?
So if it
It's
was
pretty accurate.
51 right on the button, it would be 20.86.
So let's just say we wanted a delta enthalpy of a unit.
Okay.
Let's just say I don't know. Let's just pluck a number, right? Let's just say this 2886.
All
Let's
right.
say we measured that on the return side. Boom, boom, boom. Right, and then let's say the supply side we had less heat content in the air, so we would have a lower enthalpy measurement. And let's just say it's this, I don't know, 2109, right?
Do it.
2109. All right, do some math for me, Mike.
Oh, heck no.
Hold on, let me pull up a calculator. I'm not good at doing math in my head.
I'm bad at math.
So 28.85 minus
28.8.
21.09. Okay, and what does that leave me?
I got 7 points.
7.76. Okay,
That's what I
so
got.
so I'm just gonna put this here, 7.76. So that oh,
Yep.
that
Fat pig.
is that's my delta enthalpy. And
Mhm.
what I mean by that, if I were to put a probe in the return duct, that'd be my return measurement, and that would be my supply measurement. What this is my work. This is what this means. That's the work. And what do I mean by work being done? Like if you've ever wanted to understand enthalpy, this is what I'm trying to say.
Okay.
Work. What do I mean by work? That is the sensible and latent heat that the evaporator coil is stripping out of the return air. Right? That's that's what's happening, right? Like that 7.76 describes the total sensible and latent heat that was in the return air that is no longer in that same air that's in the supply. The coil stripped it out, and we measure that in work done, and we're calling that enthalpy, and that is
Okay.
the delta enthalpy, right, of what
So I
happens across
just
that
I
evaporator.
just Googled what does delta mean, and it means the difference between two things or two values.
Okay, so you're grounded with me there.
Gotcha. I had to Google it.
If anybody in the chat's not grounded, just throw it out in the text, and I'll try to like hit it again or whatever I need to
Yeah.
do. Okay. So here, when people call me and they're like curious to try to figure out when there's this question going on, I literally go straight to this. This is what I do. Um, I run out. I first explain. I explain always like the same equation, like 4.5, and I put this in gold because I jokingly call it the gold standard, right? 4.5 times CFM times delta enthalpy equals BTUs an hour, right? And this is the example I love to always use. 4.5 times 1200 times 6.6 is basically 36,000 BTUs. Boom. That's like a 3-ton unit. Cadillac right there, right? That is 3 tons of work. And that's what the numbers look like. Like whenever you're using this formula, the formula is great, right? 4.5 CFM delta enthalpy, but you got to ask yourself, well, what's a normal enthalpy measurement? Like what should I be looking at as like a basis of knowledge to know like, well, where should I start? What is good? What is high? What is low? And what I'm telling you is 6.6 is the gold standard, right?
Okay.
And nominal CFM, how did I get 1200? That's 400 CFM per ton. It's a
Okay.
3-ton. That's 1200 CFM. Very standard, right? So
So
Think
6.6 is like your golden ratio for like nominal enthalpy.
think of the 6.6 as like 400 CFM per ton. It's like a
Right.
staple that I
It's
use to
like a
go like,
staple.
okay, this is what a perfectly operating system, these, and this
Right.
is in a theory mindset, right? When all
Yeah.
conditions are like ideal and you're just trying to throw out a nominal formula, this is
Yeah.
a good place to start, right? 4.5, 1200 CFM, 6.6 is a 3-ton unit, and you'll get about 36,000 BTUs out of it. Okay, so
It's a good check.
things are going to change, right? That's not every system's not going to measure that way. There's going to be
Right.
situations where you have really high enthalpy, you have really low enthalpy, and you got to start to like use that brain to say, okay, well, does this sound
Right.
right? And this is where my slides are going to get a little bit weaker because I ran out of time.
So does it get
But
weird when you get a big evap coil on a 3-ton condenser, like a 4-ton?
uh,
Or did I just throw you way off?
let's go to the
I messed your flow up, dude.
let's go to the
Disregard me.
next let's
Keep
go to the
going.
next page.
Keep chewing along. Disregard me.
All
I'm
right.
just hanging out for the ride.
All right, let's go to
What you got?
real data. Okay.
Let's do
So
it.
this is a capacity chart from a piece of equipment. And the text is really small, so I'm going to blow it up as I talk. But let's just say we're at a job
Yep.
and we run out the measure. Well, first off, we should know what the unit should be doing, right?
Right.
And so we measure conditions. So I'm just going to blow this up, right? Let's just say the outdoor ambient temperature is 95 degrees, the
Mhm.
indoor temperature is 70 degrees, and the airflow is 1220. We should be getting a capacity of 33,600 BTUs. Does
Okay.
that make sense?
33.
So I'm gonna do this right here. 4.5 times CFM,
Right.
1220 times delta enthalpy, which we don't have.
We don't have it. Okay.
Right, we had to go measure it, but let's just say it's 6.6.
Right.
Yeah,
Let's use our
let's just try that right now. See what happens. All right,
okay.
so let's go. I'm gonna go to my calculator and just crank that out.
It's our little
See how
brake
close
check.
we are. Yeah. So 4.5 times, and
Oh yeah.
I'm just riffing right now, man.
I'm gonna double check you.
Okay. All right. So
4.5.
so that is gonna give me 36,234 BTUs.
That's what I got. My
Right.
my
So,
calculator is the same one that you bought.
so that capacity, right? We measured over here is 33,600. So our capacity on the chart is a little bit less than what we are calculating using the 6.6.
Okay.
So, you know what I'm saying? The airflow could be so the enthalpy probably needs to go down because let's say we're not doing that much work. Let's just try 6.0 just for fun, right?
That's what I was thinking. Yeah.
I'm just going, man. Like non
Wang it.
this is what it kind of feels like in tech support mode, right? Trying to explain
Right.
1220 times 6, 32,940.
32.
32,940. Okay. So
That's close. It's a little blurry on my screen. Was that 33? Pretty close.
30, yeah, it's close to 33. So obviously the enthalpy on this machine, you
It
know,
went down.
you measured, right? So you see what I'm saying? Like enthalpy is going to drive that capacity part of the equation. So is CFM. Those two matter a lot. Now, go girl, go. Getting
Go
deep. It's getting deep.
get those Barbies.
That's right. All right. Now, this is when the unit is at 95 degrees, which is pretty hot, right? It's pretty hot
Right.
outside. And it's,
That's max for my units over here.
yeah. So notice on the chart up here, I'm just going to blow this up. The chart, the outdoor temperature kind of goes to like 65 and pretty much stops there, right? Because like there comes a point you don't need to run your air conditioner anymore. It's too cold outside.
Yeah.
So the
Jim
chart is
Bergman says
65.
70, right?
I don't know. Different strokes for different folks. You know that.
I
But
like
here's what
that
I would
show.
say. Let's leave the indoor dry bulb alone. Let's leave the
Okay.
airflow alone, and let's just change the outdoor temperature. Meaning, let's let this machine act like it's easier to work, right? It
Mhm.
doesn't have to work as hard to do
Like a
work.
nice
Yeah, like
even condition.
the condenser's outside cruising along at a very comfortable temperature and not having to work against a hot outside air conditioning.
Right.
Okay. So that's what this chart's going to show, right?
Yeah.
So this is all a 3-ton unit right now. Okay.
Mhm.
So now we're going to drop the outdoor temperature to 65 degrees. Indoor still 75 degrees. Let's just say there's a
Mhm.
heat load. I don't know. And let's say the airflow is 1220. Look at our capacity. It goes to 39,000 BTUs. Okay.
On
Now
a 3-ton?
it's a 3-ton, right? So there is a chance you could get marginally higher than the 3-ton unit by
Is
a
that what you
little.
call is that really superheat right there? That's superheat.
Well, I'm just saying it can happen. You know what I'm saying? In a low
Wow.
ambient condition outdoors, the thing doesn't have to work that hard. You can get a little bit higher than nominal capacity. But you're not getting, this is what I'm trying to say. If you look at this chart,
Right.
and units don't get more impressive than one's not a million times better than the other. They're all nominally the same, whatever.
Right.
But
They're
look,
all rated, right? In a
so
lab.
so you're not even getting numbers here. All right. But let's just say if you look across the board where it says MBH, right? Spitting out capacity, this is probably the highest rated capacity that I see on the chart. You may get
Okay.
okay, 395, sorry. If you actually jacked up the airflow and kept the enthalpy the same, looks like you could get just a little bit higher. 39.
Oh, wow. So if you go like 400 CFM, I mean, like 450,
Yeah, if you raise the flow, you can get a little bit more capacity. But here's
because
what
you
I
get
will
rid of the you get rid of the latent, right?
say. Yeah, you do less latent work. Right.
Right.
Oh, you make a good point. You make a really
Yeah,
good point.
just throw that latent out.
Let's just carry this equation. All right, what I'm doing is I'm going to the previous page, taking
So
all this math, and I'm bringing it to the next page. All
right.
right, what I just
So
did.
what Chris is trying to say is grab bags of ice and get your condenser to 65 degrees when it's 95 out.
Yeah,
Right? Am I hearing that right? You
this is
heard
why
it?
this is I think the whole theory where people put the spray misters on their condensers.
Yes, that's
Oh,
what I was getting at.
this is
You
what
heard
they're
you
doing. That is
heard it.
why.
You heard it on the grapevine.
So 1350. Let's just change this to 1350 and see what happens. Right.
Okay.
All right. Let me go to my calculator. This may
We
be
had to do
boring,
that.
but it's essential. You know what I'm saying? This is
I
this
had to do that
has
on my
to be this.
father-in-law's. We had like 20 people over for a birthday party. I had to throw the mister on there.
All right.
No?
So when I run this equation out, 36,450. So you can
Mhm.
see from the previous equation, same airflow.
Okay.
I'm sorry, different airflow, 1220. So right about the nominal flow, we had 32,300, about 33,000 BTUs. We kicked the airflow up, 36,000 BTUs by the increased flow. All right.
Nice.
So higher airflow, higher capacity, as long as the work stays the same. The work, right?
Right.
6.0, the work. All right. You with me?
Same
Everybody
temp
with
inside, same temp outside.
me? Okay. So all of that being said,
Mhm.
this is I'm just kind of dialing back to like my premises of like everything is if you can understand the total heat formula, right? And you can understand, and I just kind of have this here as an example. I was going to create more examples and I got lazy, blame my kids' baseball tournament for running later, else I'd have more data. But if you can understand this on the page and then you can manipulate it, you can decide for yourself if the airflow tool, right, is telling you good data or it's telling you data that you're maybe not getting because maybe there's a situation going on. Like let's just say you have a
Right.
flow hood and you are not measuring all the airflow through the return and you're getting a really really low airflow measurement. So, for example,
So like duct leakage or something?
yeah, I'm just going to say let me just riff for a second on the screen. 3-ton unit, right? And just put that in the corner. Put an asterisk next to it. We're just sticking here to make things easy for this show.
Yep.
3 tons, right? Boom. That's what we're working with. This is what we got, or what we'd like to have. Now, let's say we were using a flow hood and we just are not getting all the airflow through the flow hood because we're just getting a bad flow measurement because we have return duct leakage. Let's just say that's what's happening. Okay.
Okay.
So let's
Gotcha.
say we take probes and we're getting the measurement 6.6, right? Our delta enthalpy looks like we're doing a ton of work, but our flow measurement is 800, right?
Okay. Right.
So let's just say we got a bad flow measurement. Now let me calculate that out.
And just to recap, you got probes in the return, probe in the supply,
That's right.
right? For the rookies, you know.
Anybody, man. We're just talking it out.
Yeah, anybody. Yep.
It's a
That's
refresher
right.
course is what I call it, right?
The heck are these
So,
guys talking about, right?
so this would be your capacity, 760.
Okay.
Okay. Now, here's what would go through my brain if this was my situation. If I could read an enthalpy of 6.6, okay, as the work being done, um, and I have an airflow measurement of 800 CFM, and I had a capacity of 23,000 BTUs on a 3-ton unit, and my
Right.
outdoor conditions were decent, meaning I know, like from this example, I could almost get 3 tons of capacity out of the system, and I'm almost 10,000 BTUs short.
Oh man, get the jug of gas. Get that R22.
No, man, absolutely not. But hear me
I'm,
out.
I'm sorry, bro.
This is where
I
you
had
got.
to.
This is where the rubber meets the road, man. You got to
Yep.
ask yourself, why is the unit not freezing up? Is
Right.
the unit so you know is the
At eight
unit
at 800 CFM.
is the unit freezing up? Like, this is
Yeah.
the question you should probably ask yourself right there. What
So
Why is my unit freezing up? You know what I'm saying? I was like,
right.
like if I have that low of flow and I got work being done,
Yeah.
maybe I have
And,
duct leakage.
and you're at 266 CFM per ton.
Yeah.
That's my frost
Yeah.
line. Like
So
280, I think. My
so
rule of thumb.
this story would be duct leakage if the unit's
Yeah.
not freezing up, right? You have heat coming in from somewhere and it's showing up in your temperature measurements,
Right.
right? That is the story. Like, there could be other variables, but more than likely that is probably the situation that's happening right there. You know what I'm saying?
You got to put
This is,
return duct leakage,
now
right?
let me play another angle here of how I would use this formula. Let's just say use a fan curve chart for the piece of equipment. Who, for the life of me, fan curve charts are treated like, I don't know, like purity. All right. There's other words I want to use, but let's just say it is gospel. And I've seen this situation. And let's say I get a phone call and they say, well, the fan curve chart, according to the static pressure, I should have an airflow of 1600 CFM. And my delta enthalpy is 6.6, right? And you're asking yourself, okay, I've measured flow with 2 devices or 3 devices, and my fan curve chart tells me I have 1600 CFM.
Okay.
Well, this is the question you should ask yourself then. Let's just run out this formula: 4.5 times 1600 times 6.6. I'm going to just put the numbers on the screen.
Mm-hmm. Oh boy.
Okay, now
On a 36,000 BTU unit.
yes. So ask yourself a question. There's 2 big variables here that we discussed, right? Delta enthalpy here
Mm-hmm.
and CFM here, right? So looking at just a random capacity chart right now, this one, we just looked at if conditions were 65 degrees outside and you were still running your air conditioner and you actually had a high heat load on the inside, which is probably kind of rare in a home, to be honest with you. You
Super,
could get
super rare. I'm going with that.
super rare.
You let me say it.
All right,
Super
you
rare.
say it. Yeah,
Yeah.
super
All right.
rare. You would get
Yeah.
3,000 BTUs over the nominal capacity of this particular unit. Okay. So, do you think that this 3-ton that we're making up can produce 47,520 BTUs ever?
Yeah. That's ice cubes
Not,
in a
yeah,
return, maybe.
like that's, we're going to just say, not going to happen.
Not
Right.
gonna
Not this ain't gonna happen. That ain't real. That is unreal. So then you got to
So
ask yourself
if
the
you're
question.
good at taking ABC tests, you gotta go.
So ask yourself
If
the
B
question:
is off,
do you think you have a bad flow measurement from the fan curve chart at this point, or do you think you have a bad delta enthalpy measurement? That's the question you have to ask yourself. And then to take that a step further, what's the system look like? Do you have a dirty
right,
filter? Right? Do you have a dirty coil? Do you have a high static? Right? These are the next questions I would ask myself. Because if you more than likely have any one of these, you don't have 1600 CFM out of a 3-ton system. You just don't. You're not going to get that much flow. Probably not. I mean, there may be a fan motor that's out there just pumping, right? But if it's fighting stress from a dirty coil or something, more than likely you're not getting 1600 CFM. It's
right.
just not happening. Which
Okay,
means this capacity is not real. It's not real. So you have to start thinking about, okay, what am I chasing down? Is my enthalpy right or is my airflow right? And I'm just going to say it in this example, more than 99% of the time, it's going to be a flow measurement problem, right? You need to look
high
into this.
flow.
You need to look into seeing why that's wrong, because it's wrong. Because the formula is the gold standard, right? Um,
The
so
6.6 you're saying is usually pretty close. Okay.
staple. All right, so
Yep.
let's
Yep.
go to another example. Am I boring you, man? Am I
No,
boring people
I'm
in there? Like,
soaking it in, bro. I'm soaking it in.
if I'm boring, just say so.
I'm just a dude playing a dude disguised as another dude.
I don't know. I'm just telling you, like, this is the typical day of my life right now, man. This is what's been hot on the burner.
You take a lot of these calls. Okay.
Yeah. So, and this is the process I go through. So I
Okay,
thought it'd be
cool.
fun to share it. All right. So let's play out this scenario.
I just get my true flow grid out. That's all I do.
All
I
right. Hear
cheat.
me out. Let's say the flow is 1200 and your
Mhm.
delta enthalpy is 8.6. Okay. So like that's a lot of work being done, right?
So that's a lot of BTUs.
Actually, let's do this. Let's just say high flow, high delta enthalpy, right?
So a big enthalpy. We're doing a lot of work, you're saying.
A lot of work, tons of work out of the system. This thing is a beast right now. Just you got to just see what the numbers look like, right?
Okay. Yeah, let's see. Ooh.
Yeah.
She
All right.
good.
So
Get
so
that paperwork signed up. She's running real good.
all right. So you have to ask yourself now, right? Is is at this point, and this is a tech support call. Literally, this is, and I'm not
Oh,
picking.
really?
This is real life right here.
So why is my
If
3-ton running like a 5-ton?
So if you run the formula out, you're going to get 54,000 BTUs. Okay.
Woo.
So then you have to ask yourself this question: what's real? Do I have high airflow on a 3-ton and high delta enthalpy on a 3-ton? And am I actually going to get 54,000 BTUs out of a 3-ton system? And I'm just, no. The answer to that is
No. But
absolutely not.
but
Like,
it's good
no, that,
because you're basically, I mean, this is how you troubleshoot low voltage. It's like,
yep.
you go through
I,
the
I,
process.
I am literally just trying to get
Right.
this out, right, as a resource to say, how do you use this equation when you're in the field to
Yep.
evaluate when your numbers are kind of coming in sketchy, right? And you're
I
like, ooh,
like it.
this doesn't make sense. This is my process, right? And so this isn't real. Like this is not what you want to like. You don't want to pass this to the homeowner and be like, man, your unit's amazing,
Right.
right?
And
Like,
that's why you showed the chart that our
yeah, that's why I
extreme
started with the
is
capacity chart.
our
So
capacity chart. That's our max on a 3.
now here's the next move. If this happens to you, what should you do? Um,
Now, don't call Chris.
no, yeah, call me
He
and let's
seems to be
talk.
He gets plenty of these.
This is what I would do. I would take more enthalpy measurements. What do I mean by that? I would I would chase down a couple different places in the supply, see if it stays the same, right? I would maybe see if I have return duct leakage, probe around with the probe in the return side and see if you have return duct leakage, bringing that heat content way up, right? Um, I don't see tons of it's been my experience that if I'm in the ductwork and I'm close to the equipment and I'm out of the way of in line of sight or really really close to the coils, that my enthalpy is going to change drastically, moving it within a couple inches. I haven't seen
Okay.
that personally, right? And so I would probably be looking at flow at this point. That's what I would be chasing down. Like
Okay.
in my question, I would be questioning the tool's measurement right now and saying, okay, what is up with this flow measurement? Because my 8.6 is in check. But it's real easy to move a probe around fast and keep checking this out. That's the move to make. Bam, 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 bam. Does it stay the same? If it does, you got something reporting bad flow.
You know that this reminds me of when I had bought, like, before I had my field piece probes, I had testo probes, and I was trying to do this, trying to figure out, and I had nothing to measure airflow, and I was playing with, all right, what does it look like if it's 300 CFM, 400 CFM for this particular unit? You're
Yeah.
bringing me back, man, nostalgia.
All right. So,
What are a lot of the guys that call into your into the hotline? I mean, you getting a lot of
well,
auditor guys, maintenance guys,
no, it's a lot of HVAC people because I take
HVAC
a lot of
dudes.
the HVAC calls. Yep. And so
Dude,
it's a lot
finally,
of, and
guys are
I
doing
get, I,
BTUs. All right.
well, this
I
is
love it.
just, this is what happens, man. Obviously we make an airflow tool.
Oh, yeah, that's right.
It's one of these tools on the screen. Actually, there's three
Uh,
tools on the screen that we make that can be used for
is it the
measuring.
ugly one? No, I'm joking.
So, and I get the calls a lot, and the trickiest ones, if I'm being realistic with you,
Yeah.
this is like these are the hardest calls. Meaning, this
Mhm.
situation plays out. 1250,
Okay.
right?
Which seems normal for me for a 3-ton.
Right, and I don't know, 5.9. Let's say that, and
5.9.
then
So that's below your golden
yeah,
ratio.
let's play the Chris's worst day out. Right.
This is a Monday call.
This is a
And
Monday, like, here we
yeah,
go.
it's Monday, 9 o'clock, and go.
Yep, exactly. This is the worst days at work right here.
This
One
is, like, right before lunch.
yeah.
The
All right,
coffee's empty.
so this situation happens. Okay,
Ooh,
I measured this with one tool.
right.
Actually, I'm gonna clean some of this up. There we go.
All right, all right.
Let's say I'm gonna say tool number 1, right? And then I'm gonna say, let me put this over here. We're gonna say tool number 2. Like I said, man, I'm just riffing, didn't kind of build this out, but I think it's more fun to just have fun and play this out. And
You're
then
saying
this
if they've
measure,
got, like another set of probes or something, you're saying? Or airflow?
let's just say this happens, right? And I can't do this math in my head, unfortunately, so I'm gonna be slow.
You need me to hit a calculator up? You good?
Oh, I got it.
You got it?
Okay. 29, 736. Okay. This is the hardest day at work right here. You got tool number 1 spitting out an airflow of 1250,
Mhm.
and you got 33,000 BTUs. And then you got tool number 2 splitting out 1120, not too crazy far away from the 1250, but noticeable, spitting
Right.
out 29,000 BTUs,
Ooh.
right? And so people care about this, and they should. right? Because there is a noticeable 4,000 BTUs difference. That's something you want to pay attention to. But it's not so far of a spread to where you can just kick something to the curb and go like, hey man, look, this isn't even real on the capacity chart, right?
Oh, okay.
Those days are easy, right? Because I can say, well, look, capacity chart doesn't even go there. It's not even possible. The highest it goes is 39,000 BTUs. You're reading 44,000. You know, there's probably an air, probe around, get a bunch of enthalpy measurements, make sure that's right. If it is, the airflow, something you're measuring with is whatever tool you're using right now is a bad flow measurement. So that's an easy one to work out. The hard ones to work out is when they're close
Right.
because they're both realistic. Both of those capacities exist on this
I
chart,
agree. Yeah.
right? And now you start thinking like, dang, now it gets really interesting. Now you got to start asking the tough questions about, did you do a duct leakage test?
Right.
Right?
Because that's normally what I see on
Yeah.
new construction.
Where is the probe? Right?
Right. Right.
Um, are you picking up heat gain in the duct in a hot attic? Right? Like these are
Right.
the questions you have to start asking yourself because you're not splitting hairs, but you're close to splitting hairs. Now you have
Right.
to start thinking, woof, like now it's getting real. Now you're starting to say, okay, did you air seal the cabinet? Right. And I seen Doug Crawls in here. I'm just gonna like look, there he is. Keep ducks out of attic. That guy knows exactly what I'm talking about right now because he's the only guy that I've ever seen send me data on a duct leakage test where the rings we make don't get the job done because it's that tight, which is crazy. I don't know how he does it and actually makes money on a job to get the air sealing down that
Like,
low.
yeah, making money is a different story.
He does it. It's impressive.
I,
But
I told them put tracer gas in there.
yeah, Doug's a beast. But yeah, so these are the troubling calls, and these are the ones that I would say is the hardest for anybody in the industry, whether you're a technician in the field, whether you're in tech support trying to help somebody in the field. This is where the rubber meets the road. This is where it gets hard. When you are talking about 3 to 4,000 BTUs of capacity and 100 CFM of flow difference between maybe a true flow in the fan curve chart or whatever, you know what I'm saying? Like whatever you tool you're using and you're trying to figure out what is the answer. So here's where I will tell you. Let me duplicate this. This is our next move. This is what we typically advise for those situations. We take a duct blaster and we will do a duct leakage test. And we see how much leakage the system has. And ideally, what I'm saying is if you have an air handler, I'm really going to draw it out for you now. This is going to be really ugly and really rough.
Literally.
Literally. let's say this is the unit, right? And let's
Man,
just
you're
say
quick with these things.
I know, man. It's a
That's
skill I've
wild.
acquired for having to work at TC. Oh, where is it? No, I don't want that. There we go. All right, that's my ductwork, right? Here we go. You should see it when I'm on it, man, and I'm really
Oh
going.
wow. It
Yeah.
looks like a grill.
Yeah. Let's just say ideally what you're trying to do. Oh,
You
let's see.
you got to move that whole assembly up and put the duct blaster at the
Look,
bottom.
I'm a draw an arrow right there, right? If I could have my way, I'd cap the unit right there and I would use my duct blaster. Oh, by the way, this is a PowerPoint training class. So if you want to know how to do this, go back and rewatch everything. I'd put my duct blaster
You
here.
did it.
Boom.
You're awesome.
Right.
You're awesome.
And I would want to measure my duct leakage. And this is not easy to do, by the way. But this is you want to let the rubber meet the road. This is where you do it. I want to measure duct leakage from right here. We're just going to say from point A. Point A really is where the ductwork stops. right, to right here. And you're probably wondering, like, man, why am I measuring duct leakage all the way? And the unit is also part of that. Well, normally, let's just this is really ugly, but let's just say this is a blower wheel that I'm drawing right now, right? Blower wheel's right there, right? And what does a
That's
blower
not
wheel
bad,
do?
bro.
I know, man.
That
What does
is
a blower
not bad.
what does a blower wheel do? Bam, it throws air right out of the cabinet. What does that mean about this cabinet right now?
We're all negative, baby.
It's on the negative side of the system, which means if you puncture a hole,
Yep.
right?
If you put a big fat UV in the back of it,
Let's just say you
stuff that electrical in there.
let's say you puncture the electrical into this thing, right? Right here. And this is where you bring the low voltage in.
Yep.
And let's just say you bring the high voltage in right here.
And you
And I
strip
don't know,
strip the screws on the cabinet.
let's say you strip the screws on the cabinet right here, whatever. And let's say you make a bad filter box termination right here. Guess what? Before you know it, you got 100 CFM of duct leakage right at the cabinet.
I
Okay,
think the last duct leakage job I did was
hold on. It
I
gets even
dropped it.
gets
Okay.
even gets
Sorry,
even
man.
better. Gets even better. Why is if I have the holes here
Mhm.
versus them being over here, right? Let's say the holes are here
Mhm.
instead of here. What do you think that duct leakage would be if it was the same size and it was over here? And
Oh,
this isn't measured duct leakage. This is let's strip this away.
running. You're saying if it's running or
Running.
duct leakage testing?
Yeah.
Oh, when the AC is
This is
running.
going to be more like
Oh.
50 CFM of duct leakage. Why?
Mhm.
Come on, Mike. Why?
Wow.
You know the answer to
Because
this one.
the blow is right there. It's right next to the you know,
Right.
I was gonna
So,
point at it, but I was like, "Yeah, nobody could see me."
okay. So the blower's right here and it has most of its power that it can use, or that's going to happen right next to the blower, which means if you have these holes, right? Let's just say two arrows here is the same thing as two arrows over there, right? This leakage would be about 100 CFM, while this leakage would be about 50 CFM. Why? Because the fan has more power to pull leakage close to it here, and it has
So if
less
we
power to pull leakage here.
and if we measured the static pressure at those 2 locations, it'd be
Uh,
severely different, right?
yeah. So like you would be, yeah, you would have like point zero eight. Let's just say that, right? Like that's your
Pretty low,
inches
yeah.
of water column pressure measurement. If you measured it, let's just say right here, hypothetical, right?
Right,
Then if
right.
you measured it right at the back of the unit, assuming that this duct was way longer and it had way more friction loss and all that,
Yeah, like 10
this is
feet or
let's just
something.
say this would be point 0.4, right? So like let's just say the unit's running high static and you put a probe before and after, boom. This
Mhm.
thing is running a point 0.8 inches
Point 0.8.
water column for TESP, right?
Yep.
On this unit, right? So obviously there's a lot of pressure because the motor's right there. It can do all its work right here. So these leaks are really bad because they're right at the cabinet. But if you take this measurement over here in the return duct work, it's only 50 CFM or maybe even less because I'm not actually doing the conversions right now. We could
These are
calculate
all hypotheticals.
hypotheticals, right? Super low pressure, super low leakage, right? So the whole point of this equation is if you have leakage in your duct system, where should you air seal first?
Where should you just run to automatically? I love it. I
Right
love
there.
it. So important.
You air seal at the equipment first, and then you should work your way back. Why? Because
Yeah.
it's going to be most in fact impactful next to the blower. Now, would you air seal next to a supply register here for the same reason? Not, I wouldn't say the exact same reason. This is where it becomes a different reason for air sealing, right? Let's just say this is a really ugly grill, right? There you go. Bang. right? And you're going to air seal this to the sheetrock ceiling. Now, why are you doing that? You're doing it because of leakage, right? You have
Yeah.
leakage, but let's say the leakage is, I don't know, and I'm kind of going on a tangent here, switching gears, but let's say it's, I don't know, 5 CFM, which is something, right? It matters, but why
Right.
does it matter so much right there? Because that's where the hot and the cold are going to mix, right?
Call that the thunderstorm area right there.
That's right. Let's just say because you got hot attic air, right? And what's it gonna combine with? You know what? I could just steal this one. It's gonna combine
Who's
with that air. Look at that. And they're gonna touch. And what's gonna happen? Probably can't do that one really quick. I don't think they have a teardrop for a shape in here. All right, I'm not that good, bro. I'm not that good.
Come on, you got it.
All right, all
You
right,
got it.
all right. That's
Do the
that's that's
teardrop.
my fast sweat drop right there. Okay, so
So this is, I mean, so if you've got
all
that
right,
equation, right there we go. We've got that equation, and it's off by a schmegma. That's where I would go to the air handler. Yeah, I feel blessed because Steve Rogers told me that at the symposium a couple years back, and I try to pick his brain once in a while. It's
so
dude, it's big stuff, man.
that's all I'm saying, bro.
Mm.
Now I'm done.
You feel like a backpack got off your shoulders? I feel like you had 5 of those calls this week.
I had a few calls this week. I enjoy those calls. They're fun.
Yeah, but
You
it's
know what I'm
good to
saying?
send
Because
somebody to a referenced.
well, typically I'll even learn something. You know what I'm saying,
Yeah,
on these calls because I really like when people call me with those. I'm like, please follow up with me. I
yeah,
want to know, right? Because if I know that, then I can retain it. I could share it with my team, and I can be like, man, this happens in the field, you know, and so I can be better for the next call.
and
But
what about guys out there in the field? Check your probes, make sure your supply and your return are measuring the same before you throw deployment,
very good point. That's
because
a
then
point that
you're
I see. That's something that I don't think about all the time, and that's a really really good point. How many times are you taking your probes and just like checking them against a known probe where you know the probe is measuring the
right,
right way,
right.
right? It's good to do that because if your probes are off, then you're gonna have a bad capacity measurement because your probe's off. So you
Right.
should constantly be checking your probes to making sure they're reading right.
You're gonna have a bad delta triangle, whatever you call it.
You're gonna have a
Triangle
bad
delta.
you're going to have a bad equation. So,
Right.
so
Right. I mean, guys check their you check the PSI, the PSIG on your gauges all the time. You zero them out before you do measure quick. So might as well just check. Make sure that's one part of your equation that's just spot on, right? I mean, that would give a really weird enthalpy, right?
that's all I'm going to say right there, man. That's all
Mhm,
you.
mhm.
You don't even need tech support. You just need that equation. You know what I'm saying? That equation just does it for you, and you need to know how to like work that equation around, right? Knowing what the normal should be, right?
Right.
Keep that this right here. I'm gonna move this over here and just kind of put it next to it. Boom,
How
right?
many times have you got
This
phone
is
calls this year where guys had heat kits stuck on with coolant?
very
One
rare, very rare.
very rare.
Yeah,
Yeah.
I've ran into that a couple times in my career, but I have rarely. If
So
I can't even remember one call where somebody we played this game and they had a heat kit stuck on. I don't know why, but it just doesn't happen. I guess I think people figure it out before they call in. To be honest
I
with
was
you.
trying to help out Adam for Comfort Max, and that happened to me.
Oh yeah,
Just an idiot. I'm an idiot.
yeah, yeah.
$600. That's your bill, idiot.
So that's dude. That's all I got. What So I'm gonna look at the chat and see if the chat's got any questions.
That was
But
a hell of a show,
oh,
man.
I just about cranked out an hour doing that. I'm just saying.
Can we can
I,
we do that once in a blue? Can we do
think
that more often?
I think so. I think I'm gonna have to just like save this equation, bro, or save this PowerPoint, use it somewhere.
Yeah. Just we'll call this episode "Let's Make Mike Smarter" or something like that. Let's
Oh
smarten
man,
Mike up.
yeah. No, it's all good.
Yeah, yeah. I mean, and duct leakage is huge, man. Especially if you got the air handler in an attic, you know?
Yep. Air handler in the attic. Yeah. You should probably,
Huge.
how do I say this? If you run into this problem where you're getting high enthalpy and low flow in your duct systems in the attic, you should probably look for duct leakage. You probably are sucking in attic air. It doesn't take a lot of attic air to make that delta enthalpy start going way up, and then things get really weird. But yeah, I'm just saying, like,
Yeah.
if you call me on a flow, if you're questioning your tool, any tool, this is the equation you should be playing out. If you call me, this is the equation that I'm going to play out. Like you
Okay.
just like that is literally what my world looks like in a situation where flow measurements are being compared. And now, looking at this resource, you understand like flow and enthalpy aren't going to be high at the same time because the capacity is off the chart and it's not realistic. So something's not right. Right. So then you have to start, investigating at that point and seeing, well, okay. And like I said, I always start with probes and enthalpy and trying to make sure that's right first because that's the easy and fast way to dial something in and
Right.
then start running the equation again. Does it make sense? Then start chasing flow. Yep.
And, Jim Bergman's big on throwing probes in the grills for supply, and the same thing, I guess, goes
I
for
would I would say so Jim says to put like the supply probe in the closest grill and put it
right,
in the grill. In the
way up
grill. Do
inside.
not surface mount it, right? Because you have entrainment next to the grill, so you won't get the right
Yes.
measurement.
Watched a
And the
guy
reason
do the maintenance like that on YouTube, and it was just I was dying inside,
and the reason
right
he
on
said
the outside of the grill.
yeah.
Oh,
So I will tell you, I've played around with a unit with trying to get the whole radiant cooling thing. I had a furnace and a coil, and
okay.
I had a plenum at a house that was like a nice 6 foot plenum. And it's been said that you can get radiant cooling to affect your probe measurement. Like you'll get a false cooling, which looks really high if you put a probe in line of sight of the coil. And I've only
Right.
done this once where I was actually paying really close attention to it. And I probed this duck every 3 inches to see when it would
Pick
change,
up the radiant.
pick up the radiant. And then I went
Okay.
to the closest grill. I also got in the ductwork after it made a turn. So I had a good baseline. And I
Mhm.
will tell you that once I got about three, trying to remember, this has been a long time ago. I'm gonna be safe and say 4 foot. I want to say it was 3 foot, but it may have been 4 foot. But let's just say for safety reasons, I know I was at least 4 foot away. But once I got 4 foot away, I was getting the same thing I was getting out of the first grill. So if you can't get out of line of sight, which is I don't know why you wouldn't be able to get out of line of sight, but if you can't, I would say you need to get. Let's just safely say you got to get 4 foot away, right?
On return
Because if
supply.
you're getting within 2 foot of that coil, you might be picking up
Okay.
radiant cooling at that point.
Okay. Okay.
Yeah. Yep.
Yeah, that's wild. Damn, 4 foot. Goodness
Yeah.
gracious.
I know. Yeah.
I had my Haven inside the return, and it was picking up some wild readings. Yeah, it's you got to have a little bit of distance.
Yeah. All right, man. That's all I got for tonight.
Right on time too, bro. Woo! You're
Woo!
an expert, bro.
Until next week.
All right, guys. Thanks for coming. Thanks for hanging out. I appreciate you guys. Catch you on the next one.
Later.